This is Intelligence Explained number 5. So to begin with, brain cells are routing systems. They channel energy so that other neurons can receive that energy, and when they receive that energy, they direct that energy also based off of just like multiple connections that they're already connected to. So just like on the internet, a signal has to go somewhere, and so it routes it. It says, I can't go in that direction, and so I go in a different direction. And so directing the channel signals. So how do you direct the channel signals? You have to change where the wire is pointing. So this is virtual in a like a transistor doesn't really move or anything, but a neuron actually changes where it's pointing to send the signal. And so the thing is that if you think about when you tie your shoes, that when you tie your shoes, you have that your hands are changing the way they do things. Like it's exactly like brain surgery. You're tying little knots in the brain so that you suture the wound, or that you're manipulating things. So the thing is that when the brain cells route signals, it's changing how the body is moving. And so the thing is okay, I may ramble a little bit, but hang on. So the thing is that an attractor network is what the brain is. An attractor network decides how to move the muscles. So it's very complex tying your shoes. So a robot cannot learn how to tie a shoelace from scratch. It has to be pre-programmed exactly. When a child is learning how to tie its shoes, it's learning how to pull back and push forward, to put its finger on the knot, twist it around, and then pull it to tighten it. That is an attractor landscape. That is the ability for the brain to wrap around, to inhibit one area of the brain, and then direct the signals in the brain to change basically where the hands are moving. And so when you are tying your shoes, the brain is inhibiting different parts of itself. And so it's just like step by step by step. It's like solving a puzzle. When a high-level gamer is solving a high-level puzzle, they're taking all the parts together, and they know that they have to shift and push and pull and do all the steps necessary to solve the puzzle. Because and so the thing is, it's pushing and pulling, and the brain does that non-linearly. So that means that it knows that it has to push and pull multiple things at the same time. And so the thing is that the brain does that by a router system, and that router system changes how it routes the signals inside itself, and it does that with memory. And so by having memory, it can learn different ways to route for the attractor landscape to solve puzzles non-linearly by pushing and pulling non-linearly. So I don't know how this would be mathematically described. I don't know how this would be put into a computer for an artificial intelligence, but I do know that the routing system directs traffic, and it has memory so it can remember how it directs traffic, so that it can solve puzzles non-linearly by pushing and pulling non-linearly the pieces in steps to solve problems. And so I guess I've solved problems before, non-linear problems with multiple pieces and multiple steps, and you had to do some steps before other steps in order to actually make it work. And so, I mean, I made a computer program where I had to actually say, okay, well, this goes first, this goes second, in order for me to solve this problem, this has to go inside this other thing. And I guess that's a puzzle too. And so the thing is, like, the router system in the brain has memory to solve problems non-linearly, push and pull. I can't say anymore, so I'll end the video. But that's another way. That's me explaining intelligence. I just had to say it. So I hope you get it.